Okay, welcome to the third CREO tutorial. In this tutorial, we'll be covering how to draw spur gears, which will then in future weeks lead into how to draw helical gears and worm gears. So the main point of this tutorial will be how to use the parameter and relation functions to get CREO to solve all of your mathematics for you, and then the sometimes finicky process of drawing a gear, which you will need to follow very precisely because even small deviations such as leaving a single line out in your sketch can cause it to not work, and it can be very frustrating. So first thing I want you to do is open a new part. Now it's very important that you work in the XY plane because the basic gear equation that I'm going to give you, that I'll post up in the week's notes, is based around involute curves in the XY plane. You can do it in the XZ or the YZ planes, but that just requires changing things, and it's frankly unnecessary. So I want you to start by drawing a circle in the XY plane. Don't bother dimensioning it just yet, because we need to add all of the parameters and things first. So then I want you to go to Tools, Parameters, and I want you to add a parameter called pressure angle. And we're going to give that a value of 20. Then add another one called module. Going to give that a value of 7, and then another one called NO of teeth, number of teeth. And now it's very important that you add these here in exactly the same way you define them in the relations, otherwise CREO won't call the correct values. So here where I've called it NO of teeth, if you call it number of teeth, then in the relations you also need to define it as number of teeth. The relations are just the set of equations that describe the design of gears. They're the exact same as they are in your textbook. I've just pre-written them all, which I will post up in the week's notes. Now add one more, and we're going to call it width, and give that a value of 25. So these are probably look a little bit familiar, given that you've studied gear design in the last few weeks. So now that we've got the base values, these are just the ones you need to define for any gear design. Now we're going to add the relations. So you'll get a window that pops up like this. You're looking in part, this is the current part, and this is just a space for defining a series of equations that will tell you things about the shape of your gear. So your basic gear design equations. So basically we want to copy these and paste them into here. I will put a copy of this up in the week's notes, so you can just copy and paste it because that's so much easier than retyping them all. So you see you've got the circular pitch, pi times moduled. We've got the addendum, obviously equal to the moduled addendum, a little bit longer, 1.25. The reference diameter, module times number of teeth. So reference diameter is what's frequently referred to as the pitch diameter. Then we've got the tip diameter, reference plus 2 times addendum. Base diameter, reference times the cosine of the pressure angle, because it's a little bit above the root diameter. Then we have the root diameter, which is reference minus 2 times the addendum, the fillet size, blah, and the tooth thickness. Yeah. If you're confused as to why this is 2 times, give it a quick think through, remembering that we're looking at diameters, not radius. So once you've put all of these in here, you need to then verify. So this little check mark box at the end here, click that, and it should say relations have successfully verified. as long as all the names for the parameters match up with the names for the relations. So you see number of teeth, module, pressure angle. Yeah. So if you've got a mismatch between the names in the parameters and the names in the relations, it won't work. Also, if you've typed out your formula wrong, it won't work. Good exercise is to actually type this out for yourself based off of what's in the book, but you won't need to do that for now. Okay, I'm going to hit OK. Now, we can dimension this circle. So, we're going to start with the root diameter. So to link the value from your equations to the dimensions in your drawing or your part, all you do is you double click on the dimension to change it, same as you usually do, except instead of putting in a value, we're going to put in root dia, standing for root diameter. And you'll get this little notification that says, do you want to add this relation, SD0 is equal to root diameter? Yes. And there we go. So you didn't even need to calculate your value. And this is good because it means you don't really need to calculate any value as long as you can translate the equations from your textbook into CREO. Okay, now we're going to extrude this, and we're going to give this a thickness of width. Okay, and now you can see if you wanted to make that thicker, you can go into your parameters, and not only can you see that all the calculated things have shown up here, which is nice. If you wanted to change one of your input values, you can. So let's say we want to make this 50 thick instead of 25. Hit OK, and now it looks like nothing's changed, which is normal. So if you go back to model and click the regenerate button, which basically just means recalculate and reload, you can see that now it's 50 thick. Just confirm, see, 50 thick. Okay, so the next thing I want you to do is on this plane here, which coincides with your origin XY plane, I want you to do another sketch. And in this sketch, you're going to have 3 circles. Don't be precious about the size you make them at this point. You just need them in there, and then we'll add the dimensions. So, we have a base diameter, a reference diameter, and a tip diameter. So, we're going to change these to link them with the relations that we've made. So, the first one is base diameter. Hit yes. Then we have the reference diameter. And then we have the tip diameter. What did I do there? I typed out all of diameter, didn't I? So you got to call it exactly the same thing or it doesn't know what you're talking about. Okay. So, now you can see that we've got all of our circles, and these circles are what we're going to use to now draw the tooth. So the next important section is to draw the involute. Because the tooth of a spur gear is, I think the standard is based off of the involute shape generally. That's what we're going to go with. So we're going to go datum, curve, and we want a curve from equation. Leave it as Cartesian. The equations we want are these ones, which I will also put up so you don't need to worry about remembering them, because these aren't even in the textbook. This is just describing the geometry of a gear, of a gear tooth rather. We call it an involute curve. Same as with relations, you just want to verify them. And if you didn't pay too much attention at the start and didn't draw in the XY plane, or just I forgot to tell you, which I did in class, all you need to do is substitute the either X and Z or Y and Z values to make the 0 the dimension in which the involute curve doesn't change. So you'll see what I mean in a second. So we have Z is equal to here, Z is equal to 0 here. And now the coordinate system that you want is going to be your origin coordinate system. So you see how we've got the Z dimension here, and the involute curve is always at 0 in the Z dimension. So if it's sticking out in the Z dimension and not in the Y dimension or the X dimension, then what you need to do is just switch those values in the equations. So if you find that that's a problem, you right click on curve 1, go edit dimension, go back into the equations, and you just want to switch the Z and probably the Y. So all you do is Y is equal to 0, Z is equal to that, ZC is equal to that, ZC is equal to that. We'll verify again, go OK, and you see it's now flipped out there. That's not what I want, because I've got this in the XY plane. So to switch it back, we're just going to swap Y and Z. There we go, verified, and back to where it should be. So, you'll see this shape starts at the base diameter, passes through the reference diameter, and up through the tip diameter. And it looks kind of like one edge of a curve for a gear tooth. So, next thing you're going to do is do another sketch on this origin XY plane. Go into sketch mode to make it easy. And we want an arc. So basically we're going to define the tooth thickness using an arc. So using the arc with two ends, click on the center of the gear. Actually, you see how that didn't click there? To make it easy for ourselves, we're going to use the references command. So top left hand corner up here, references, you'll get a little box like this. It's going to say reference status fully placed. Even if it's fully placed, you can add more references. So what we want to add is this curve here on the reference diameter and the involute curve. And then go solve and close. And the reason we're going to do that is you'll see if I take an arc, it's now going to recognize these as two very important lines, and it's going to snap to the intersection of them very easily. Then we're going to just make an arc of some length, because we know what the tooth thickness is in the relations, but the tooth thickness is defined as an arc length, not a straight line distance, which is what we've got right now. We've got the distance from this plane to the end here. So the way to change that is we're going to go dimension, going to right click on the first corner of the arc, right click on the center of the circle, and right click on the second corner, and then using the middle button of your mouse, you're going to middle click somewhere out here. And now you can see that you've got an arc length dimension. and we want to tie that to our tooth thickness. So same as we've been doing before, we're going to go tooth underscore thickness, or tooth underscore thick. And there we go, 11 millimeters. Then hit OK, and this is where it starts to get really finicky. So I want you to make sure you've got your arc selected in the model tree over here. And then I want you to add a datum point. And you see how it's at the end of the line here? So you should have your references are your curves, sketch 3, and then you have an offset reference. Now we want to go from the end of the curve, and our offset is 0, so we're sitting right at the start of the curve. Make your offset 0.5 as a ratio, and hit OK. And you see that's added your point halfway down the line. It's good, that's what we want. Because now you're going to add a datum plane going through that curve, so make sure the curve's selected, then hold Control and click on your origin axis, the axis going through the center of the gear. And now you see you've made a plane in line with that point, which coincidentally is in line with halfway down the tooth, or across the tooth. So now that we've got that, we're going to mirror this involute shape here, and then it'll start to really look like a gear tooth. So using the mirror command, select the new plane you've just created and accept, and there we go. Now it's looking a bit more like a tooth shape, except for this weird bit sticking out the top here, but that's alright, we can fix that. But this is most of the way there. So next thing you're going to do is extrude. Now this is a bit of an odd way to do an extrusion because you're not going to have a sketch already created, but it'll work. You'll see what I mean. So we're going to select a plane and go extrude. Now it's going to ask us for a sketch because we didn't tell it one to begin with. So, going into Sketch View, we're going to use a rather useful command called project. So what project does is it basically takes lines that it can see. If you're in Sketch View, it's really easy because it sees everything as two-dimensional anyway. And it makes those lines part of the sketch. It basically draws a line for you on top of them, no matter what the geometry is, no matter how complicated it is. So what we're going to do is you're going to project your tip diameter and your two involute curves and your root diameter. And now you see this isn't a closed shape yet, so we're going to take a line, and you want this tangent lock, so it needs to be tangential to the base of your involute. And we're going to try to close that gap. Yes, this can be very, very finicky. Okay. Now, you've got all these weird extra lines which are going to ensure that your shape is not closed so long as they exist. So we're going to use the delete segment command to delete them. So if you click and drag, you get this line that comes up, and sometimes that deletes things, sometimes it doesn't. The other way is to just straight click on the lines, which is often a bit easier. We want to get rid of this triangle part because that's not part of the tooth. And is the shape closed? Oh, the shape is not closed. Still got a few left. So if you hit escape to accept what you've done and it doesn't come up pink, it means the shape is not closed. So go back and look for more sections to delete. They'll all be in orange with these little boxes around telling you the constraints. Let's get rid of that one, get rid of that one. And have I missed some? I missed some. Cannot have a mixture of open and closed sections. Yes, this is the rather troublesome part with this. You've got to find all the little bits that have decided they don't want to work. And if you just can't find them, you've just got to start your sketch again. Is that one? No. So it says cannot have a mixture of open and closed sections, which means I've got an extra section somewhere. But it won't tell me where. So, try again. So, let's define the sketch. I'm going to define it in this plane. And going to project the involutes and the outer curve. And then delete these outward segments. Delete that one. Okay. And I'm going to do this a little bit differently to see if it works. So I'm going to take lines, and I'm going to do the lines like this. And then I'm going to use an arc to close it. There we go. So yeah, there's a few different ways. As long as you can get the shape of the tooth, that's what's important. And you'll need to use a combination of the project command to select the more complicated lines and the delete segment command to then delete all your little excess bits. I just couldn't find all the excess bits in that last one. Anyway, so here we've got the tooth. Now, this tooth is in the wrong direction. Slight design flaw there. So, to turn it around, you can either use this little arrow here that's going to glow when I hover over it, or you can select these two arrows up here, and they'll swap the direction. And we want this to be of width. So we're going to add this relation, hit OK, and there you go. Now you've got one tooth of your gear. Now, one tooth, not all too useful. Some cases you want one tooth, usually you want more. So, now we're going to use a fantastic little command called the pattern command. So click this box up here, looks like a little Minecraft thing. And we want to use the axis command. So there are many ways you can pattern in CREO, and it's basically along a dimension, in a direction, around a circle. The one we want is around a circle based off of an axis. So the axis that we're going to select is this one in the middle of the gear. And now you see you get these little yellow dots show up. Those are going to tell you where your patterned objects are going to appear once you've finish this once you've accepted the command. So now, how many teeth did we have? It was 18 teeth. Okay. Now, the easiest way to work out how far in degrees between the teeth is usually just on a calculator. So I'm going to do that with this one I fortunately have handy here. So we're going to go 360 degrees divided by 18 teeth is 20 degrees per tooth. Okay, now you see we've got more dots. And that basically just means at each of these locations, the pattern command is going to replicate the tooth. Like so. And there you have a spur gear. If you want to, you can turn all of these off. You can even hide these if you want to. If you want to make it look pretty. So the final thing you can do that you really should do for your gear design is add fillets to your teeth, because you won't usually find gears that don't have fillets. There's a massive stress concentration without it. So using the round command here, just click on the edges, and we defined root fillet to be the thickness. So root fillet. Okay. And then just go through and add those to all your teeth. Have fun with that. Okay. And then you see you've got that nice characteristic involute gear shape. Okay. So that's the basics of spur gears. In the next video I'll cover helical gears. Okay, see ya.